Hi there, welcome back. This is Weblan. I want us to look at a few trigonometric questions. These ones are identities, trigonometric identities. I'm starting with this one. This one is coming from a grade 12 past exam paper. It's 6 marks, but it's from grade 11. There is a number of things that you have to know for you to be able to do these questions. You need to know the reduction formula. You need to know the co-ratios. You need to know identities and special angles. All right, the first thing, we need to reduce these angles. This is an identity, and to deal with an identity, you need to simplify one of the two sides until it is exactly the same as the other side. In this case, I want to choose the left hand side. So my left hand side here is equal to, I have the first one, tan 408. How do you reduce tan 408? One of the tricks that you use here is to subtract 360 from 480 minus 360. Remember, 360 is a complete revolution. If we add 360 to an angle or subtract 360, it does not change the position or it does not change the value. So in this case, subtracting 360 from 480, we have 120. So this is the same as tan 120. It is still at the same position, right? And this one, which quadrant is it? It's quadrant number 4. So you can write it as sine 360 minus 60 there to get 300. And then this one is an acute angle. Leave it as it is, cos 14. And the last one, you need to take the negative out to make it sine 135. And this is all over 104. It's 104 is in the second quadrant also. So this is sine 180 minus 76, and this is the third quadrant, that is cos 180 plus 45. And then this is equal to tan 120. Tan 120 is equal to tan 180 minus 60, right? And this is the second quadrant, and this in the second quadrant it gives us negative tan 60. So this is tan 60, which is negative. This is the fourth quadrant, and sine is negative in the fourth quadrant. So this is negative sine 60 multiplied by cos 14, and then 135 negative sine 135 is the same as negative sine 180 minus 45. This is the second quadrant, so we don't have a negative that comes out of this, so this one remains. It becomes negative sine 45. So this is multiplied by a negative sine 45. all over sine 180 minus 76 is sine 76. It is in the third quadrant, and sine is positive in the third quadrant. Cos, there is negative. Cos 45, it is in the third quadrant, and cos is negative in the third quadrant. And then from there, we have ratios that are equal to each other here. Remember, I said you need no cofunctions. 76 plus 14 is equal to 90 sine cos. So these are equal, they are cofunctions. So we cancel them, sine 76 and cos 14. And then we have sine 45 and sine 40, cos 45. They are cofunctions also, we can cancel them. So here we are left with, all right, we can deal with these negatives. Negative multiplied by a negative, it becomes positive. We are left with tan 60 multiplied by sine 60. Those are the only two that are left there. And then we have an identity that says sine 60 over cos 60 is equal to tan 60. So multiplied by sine 60 there. And then remember your special triangles. There is a 30 here and a 60 there. There is a 1 here and a 2 and a root 3. We use these small triangles for special angles. We also have the isosceles one that has 45 degrees here and 45 degrees, 45, 45, 90 to make it 180. And this is 1, this is 1, and this is root 2 using Pythagoras theorem. So from there, my sine 60, all right. This step was not very necessary. We can just get it from here. Since it is something that we can simplify, it's tan 60. Our tan 60 here is opposite over, that is root 3 over 1, opposite over adjacent multiplied by sine 60 is root 3 over 2. And then root 3 times root 3, it is a 3 over 2, which is equal to our right hand side. All right. Let's look at the second one. The second one is saying cos 75 degrees is equal to root of 2 multiplied by root of 3 minus 1 all over 4. We need to deal with this identity. In this case, the one that you can simplify is the left hand side. So my left hand side is equal to my cos 75. It's not a special angle, but we can create special angle out of this. So we can write it as cos 45 degrees plus 30 degrees, right? And then our compound angle expansion is cos 45 multiplied by cos 30, and then the opposite, so it's minus sine 45 by sine 30. And then this is going to be equal to cos 45 is a special angle, that is 1 over root 2, and then cos 30 is root 3 over 2, and then is minus sine 45 is the same as this, they are co-ratios, 1 over root 2, and then sine 30, it is 1 over 2, and this is going to be equal to root 3, that is 1 by root 3. This is 2 root 2 minus 1 over 2 root 2, which when you put together the denominators is just root 3 minus 1 over 2 root 2. Remember, we want it to be exactly the same as this one. This one, the denominator is rationalized. It's a rational number. This is an irrational number. So we need to rationalize the denominator here. So root 3 minus 1 all over 2 root 2. We multiplied it by root 2 over root 2. Remember, root 2 over root 2 can be reduced to be 1. And this is going to be equal to root 2 times this. It's root 2 bracket root 3 minus 1. And then on the denominator, root 2 times root 2 is a 2, which when multiplied by this 2 becomes 4. And there we have it there. That's equal to our right hand side. We need to prove this identity. So I'm choosing the left hand side here. So my left hand side is equal to cos 90 minus 2x. This is a co-ratio, which is sine 2x. It's in the first quadrant there. And then multiplied by tan 180 plus x. That's the third quadrant. So it gives us tan x. And then plus, this is the fourth quadrant, 360 minus x. That is negative, but because it is squared, the negative disappears. So we simply have sine x squared there. And then it's equal to, we need to expand this to be 2 sine x cos x, and then tan x changes to be x. The tan x changes to be sine x over cos x plus sine x squared. And these ones cancel each other, and this is equal to sine, and sine gives us sine x squared plus sine x squared there. And then this plus that, it gives us 3 sine x squared, which is equal to the right hand side. That's all I have for you today. Enjoy.